Okay, we're going to be graphing here a cosine function under some transformations. And I'm going to do this one the old-fashioned way, one step at a time, by just showing how each transformation acts on the original cosine graph. So let's start by actually putting that original graph in. I'm going to set up some of the key points for cosine between 0 and 360, one complete cycle. So we know that cos of 0 is going to be 1, a bit too big. Let me minimize that. Cos of 0 is going to be 1, cos of 90 is going to be 0, 180 is going to be negative 1, 270 will be 0, 360 will be back at 1. If I connect those points together, I get a nice smooth curve that goes something like this. And that is one cycle. So that's the base cosine graph. And I will mark that by saying f of theta is equal to cos of theta. Okay, now let's apply each of the transformations one at a time. First one is a vertical compression by a factor of 0.5. So basically the graph will be pushed down, kind of pressed on the top and bottom, and as a result kind of squished by a factor of 0.5. So what's that going to look like? Well, this one point over here is going to come down here. 0 will remain the same. The negative 1 will be pushed up a little bit. The 270 will remain at 0, and the 360 will be pushed down by a factor of 0.5. So what does that look like when I graph it? I get a smooth curve looking something like this. Okay, so this will be f of theta equals 0.5 cos theta, and I can't fit that in. Maybe if I take this, put it in front here, move this over, take this guy. Actually, you know what? Just to minimize clutter, let me just take out the f of theta altogether and just have the function itself. So this is cos theta, this is 0.5 cos theta, and that's where it's going to go. Okay, next we have the phase shift or horizontal shift, which I will highlight in orange. That is this here. And because it is positive 45, that means we're going to move to the left 45 degrees. I will indicate that with orange pencil. So I'm taking my last graph, which was the compression by 0.5, and I'm shifting it to the left 45 degrees. So I'll just show you what that looks like. I'm taking, like I said, my last graph, and I'm shifting it to the left this way 45 degrees. That's, again, halfway between 0 and negative 90. So I'm not going to necessarily, I guess I'll move all the points one at a time as such. So this point here, I'll move it back 45. The next point at negative 90 is 0, I'll move back 45. Negative 80, negative 0.5, move back 45. 270, 0, back 45. 360, 0.5, back 45. So I get a curve that looks something like this. Okay, it was the same as the previous one, just everything was shifted this way by 45 degrees. Okay, the last one, nice and easy, is a vertical shift down 3 units. We'll do that in red. That's this guy over here. And I'm taking my last graph. I will show the motion of it, and basically moving it down 3 units. So this would be 1. Sorry, would that be 1? No. Yeah, that would be 1. That would be 2. And that would be 3. So it actually, oh dear, it almost comes off the page. You won't be able to see it. But let's do it anyways. Let's kind of sketch it in. So down 3, so that's 1, 2. Oh yeah, this is definitely off the page. 3. So it's going to be way down here. I'm going to have to kind of sketch it down. And your graph will come up something like that. Anyways, it's off the grid. You won't be able to see this one, but I think you get the idea. So give it a try on your own. Remember, everything's moved down 3 units, and see what see if it matches up. If you want to do a comparison, you can do your work and then do it with Desmos, the graphing software. And that's our graphing of cosine under some transformations.